Okay, we are now working on Project 1, Lesson 3. There are 5 questions here, so we might need to move a little faster. Okay, when solving a crime, the difference between suspicion and certainty is evidence. Evidence comes in many different forms, and when measurements with units are involved, much care must be taken for the purpose of accuracy. Analyzing evidence and using units appropriately will be the key to solving this crime. Zachary is investigating a crime that took place at Who Donut, or Who Done It, a local bakery in the town of Marsh Meadow. Zachary saw someone in a mask run out of the store with 7 boxes of glazed donuts. Use your knowledge of units to help Zachary find out who the thief is. Question 1. Security footage of the crime shows that the thief was shorter than the owner, Bob, who is 70 inches tall. However, the perpetrator was taller than Bob's brother, who is 61 inches tall. As you know, there are 12 inches in 1 foot. So we are given a list of suspects and their heights, and we need to decide who is going to remain on the suspect list. So what I'm going to do really quickly is just divide 70 by 12 and also 61 by 12 and see what I get. So 70 divided by 12 is 5.83, so that's my upper limit, okay? And 61 divided by 12, this is my lower limit, is basically 5.1 or 5.083. Okay, so let's go back, and I know that I'm somewhere between 5.1 and 5.83. Okay, so Patty Pastry is out. David Danish is in. Bonnie Brownie is in. Corey Coco is out. Too short. Jeffrey Gelato is in. And Sarah Smoothie is in. So let's go ahead and we'll mark those. So the only 2 that we decided were out were Patty Pastry and Corey Coco. So, all right, those 4 are still in it. All right, Who Donut charges 70 cents per donut. There are 12 donuts in a box. How many dollars did the bakery lose when 7 boxes of donuts were stolen? Okay, so this is a unit conversion problem, which I actually really like these. Okay, so I've got, we're going to say this is $0.7 or 70 cents, okay? So $0.7 per donut, right? And I know that there are 12 donuts per box, and I also know that the thief stole 7 boxes. Okay, so the beauty of setting something up like this is that I can ensure that I'm going to end up with dollars because my donuts are going to cancel out and my boxes are going to cancel out. Okay, and so what I'm left with is dollars. Okay, so I'm going to take 0.7 times 12 times 7. So 0.7 times 12 times 7. My cat's coming to join us here. And I can see that this thief made off with $58.80 worth of donuts, but they ask us to, it looks like they ask us to round it to the nearest dollar. So we're going to say that this is $59 worth of donuts. Okay. I think it will also take it as 58.8. Okay. So using, okay, sorry about that. It got really loud and my cat had her head stuck in a bag and couldn't get out. So next question, use the information from the previous question, how much it costs for a box of donuts, to determine how much it costs for a box of donuts at the bakery. Explain how to convert cents per donut into dollars per box. Okay, so that is basically what we did, and we're just going to type in here. We know each donut costs 70 cents. Okay, so there are 70 cents per dollar, or this is the same as $0.7. Okay, if there are 12, and I guess let's go ahead and say $12.7 per donut. Okay, if there are 12 donuts in the box, we need to multiply $0.7 per donut by 12 donuts to cancel the donuts and leave us with dollars, and I guess we could say 12 donuts per box, and that leaves us with dollars per box. So 0.7 times 12 is $8.40 per box. Okay, that's all you'd need to type, something along those lines. And question 4. After some further investigation, Zachary found out that Bonnie Brownie and David Danish were both out of town on the day of the incident. Okay. When Zachary saw the thief running out of the store, it was 3:12 p.m. At 3:27, a neighbor saw Jeffrey Gelato arriving at his home, which was 30 miles away. Sarah Smoothie's neighbor said she arrived at her home at 3:42 and she lives 24 miles away. So it asks us to graph the potential getaway trips of Mr. Gelato and Mrs. Smoothie, showing the distance from the bakery over time. Okay, so basically what they're asking here is to have time on our x-axis and distance on the y-axis. Okay, so we're going to make time 0, 3:12. Okay, and so 15 minutes later, so at 3:27, okay, is when Jeffrey Gelato arrived home, and that was 30 miles away. Okay, so we'll say 30 miles is up here, okay? And at 3:42, which was another 15 minutes, so a whole 30, okay, 3:42, okay. Sarah Smoothie arrived and she was only 24 miles away. So if we were to kind of plot these points, Mr. Gelato arrived home. Okay, he went a greater distance in less time. Okay, so since you can't really draw a graph in here, you have to describe it. And It says what scale and units did you use? So the scale that we used would probably be 15-minute increments on the x-axis, okay? And on the y-axis, I guess you could use miles, and 1 mile would be a sufficient increment, okay? So if I were typing this, which I will, I would type what scale, so for the x-axis, I graphed time in 15-minute increments, okay? On the y, let's see, and why did I do that? I did that because each time interval between 3:12, 3:27, and 3:42 was 15 minutes apart. Okay, for the x-axis, or sorry, for the y-axis, I simply used approximately, because I certainly wasn't very careful here, 1 mile increments. I did this because all I needed to do was show that Mrs. Smoothie traveled less distance okay, that's really all you needed to show, that she didn't go as far, but she got home after. Okay, and for that reason I would say it is probably more likely Miss Smoothie, because if it were Mr. Gelato, he would have had to have gone 30 miles in 15 minutes, which is basically 120 miles an hour. Miss Smoothie, on the other hand, went 24 miles in 30 minutes, which is just under 60 miles an hour. So, based on the information given, is it Miss Smoothie or Mr. Gelato? And you could disagree with me on this, but I would say Mrs. Smoothie, because she was traveling at a reasonable rate of speed to make it from the bakery to her home, which was 24 miles, in 30 minutes. Mr. Gelato would have had to travel 120 miles per hour to get 30 miles in 15 minutes. And how do I know that? I know that I can go 60 miles in 1 hour if I'm going 60 miles an hour, okay? That means that for every minute I can go 1 mile if I'm going 60 miles an hour, okay? That means that if I'm going 60 miles an hour, it's going to take me 30 minutes to go 30 miles. Now, if I double that distance and keep the time the same, I have to double my speed. So that's how I know it would have taken him, he could have gone 30 miles in 15 minutes by going 120 miles an hour. Okay? So that's how I figured that out, and I'm at the end of my recording. Thank you!